All right. Okay, so Marley volunteers after school at a daycare. Each afternoon, around 4 p.m., she lines up her group of children at the water fountain to get a drink of water. Determine the number of arrangements that 6 children can form while lining up to drink. So we know we have six parts in the line. There are 6 sections, 6 positions in the line, right? And let's just say this is the front of the line and this is the back of the line. How many choices do we have in this first position? 6, good. And then 5, right? So we're going to keep going down because we've already chosen the first position, right? And does that make sense why we're going down each time? Yeah, okay. And if we multiply those together, sorry, 720, thank you. So there are 720 possible combinations that those students could line up in. That is a lot. And so each of those possible combinations we can refer to as a permutation, okay? So take a look at the next part here, the key ideas. We have this table showing several different permutations, okay? We've got A, B, and C, and you can rearrange those letters in this many different ways. Okay, so you can go ABC, ACB, and all those different permutations. Okay. Now, when we have something like this, we have 6 times 5 all the way to 1. We have a special notation that how we can write this. So this is, we call 6 factorial, okay? So 6 factorial equals 6 times 5 times 4 times 3 times 2 times 1, okay? And of course, this 1 here is kind of meaningless. Anything multiplied by 1 is itself, but that is part of factorial notation. So this is kind of what we're focusing on today, this factorial notation. Now, you can see here in this table we have six possible permutations, okay? There are 6 possible different options for how to arrange those letters. And we have 3 possible letters, right? So maybe you can just write this just below there. We've got 3 possible letters. So that would be 3 factorial, right? So what does 3 factorial equal? Good. 3 times 2 times 1. And what does that equal? 6. And you'll notice we have 6 permutations. So we have these 6 different permutations. We use factorial notation to find how many different permutations we can have. All right? It's the same in this one and in this one as well that we just did, right? We had 6 children lining up and filling 6 different positions. We can write that as 6 factorial. Yeah. There is. So if you go to, I believe that's under math. Yeah. If you press the math button, and then the last arrow key, and it should be right there. It looks like an exclamation mark. Okay. The PRB or probability menu under math. What is that exclamation mark? Sorry? What does that mean? So when you have any number followed by that exclamation mark, that means 3 factorial. And what you're going to do is you're going to start with this number and go all the way to 1. So 3 times 2 times 1. That's how you find the permutation. And that's going to give you the different number of permutations, yeah. Well, we'll take a look at a few. Sometimes it'll say how many different permutations are there. Um, Whenever we're dealing with permutations, order is important. Okay, it's important the order that we're looking at. So, for example, this one we're talking about the order of those kids in line. Okay. When you're talking about order or different positions, you'll use it. Sorry, it's what? Okay. How's that? That's good? Okay. Oh yeah, here we go. These are the instructions for how to find it. So let's take a look at example 1. Example 1a. Evaluate 6 factorial. You can use your calculator and go 6 factorial. I'm going to write it out here. We would go 6 times 5 times 4 times 3 times 2 times 1. And that equals, sorry? 720. Oh yeah, the one we just did. Yeah. Yeah. So good. Now, for question B, where is question B? Okay, for question B here, we have 9 times 8 factorial. There's a different way we can write this out. So if we have 9 times 8 and 8 factorial, 9 times 8 factorial, that can be rewritten as 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And how can we rewrite this in factorial notation? Sorry? Yeah, good. 9 factorial, okay? So we can rewrite this as 9 factorial. There are these kind of ways that you can manipulate factorials to make them easier to work with. So if you take a look here, this is 9 times 8 factorial, right? Which, if you expand it out, goes to this. 9 times 8 times 7, right? All the way to 1. And if you look at this, this starts at 9 and goes all the way to 1, right? 9 times 8. And this is the same as 9 factorial. What's the answer, Sawyer? One more. 362,880. Okay, good. Let's take a look at question C here. So if we just evaluate this on paper, if we expand it out, we have 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. Okay? And before you multiply these out, you can see that there are things that we can cancel out, right? Sorry? Yeah, exactly. So you can cancel out the 3, 2, 1. And what are we left with? 20? Yeah, 5 times 4. Okay, so that's your final answer. Whenever you have a large factorial over a small factorial, you can do these kind of simplifications, these kind of cancellations. Yeah. You can just stick it into your calculator too. These are good skills to have for a lot of these type of questions, because you do have to make some manipulations in some of the future chapters. Another way that you can write this, okay, so we've got 5 times 4 times 3 factorial. And from here, we can cancel out these 3 factorials. Does it make sense how I got 5 times 4 times 3 factorial on the top here, right? So that equals 5 factorial. Of course, we can cancel out, and we are left with 5 times 4 again. When we do multiplication of factorials, there's not a lot of simplification we can do. We kind of just brute force it. Do it in your calculator or just write it out like this. Okay? So what do we get? 12. Good. Thank you. Good. Are there any questions about that so far? Sorry? No. Yeah. No worries. Good question. So take a look at number 2 and see if you can work that out yourself. I'll give you just a couple minutes to do that. Okay? So we've got 3 people and we've got 3 positions in that line, right? So you could do it the way that we had been doing it. First position, second position, first position, and that gives us 6, right? Or we can write that in factorial notation, 3 factorial, and it equals the same thing. Okay? Okay, next take a look at A. Take a look at A here. How can we rewrite this in factorial notation? Okay, good. 5 exclamation mark or 5 factorial. Good. Take a look at B and C and try to do those on your own. Okay, this is a hint for question B. 9 factorial over what? Right. Because this is like a complete factorial, right? It goes all the way to 1. 6. Right. Why? Sawyer, do you want to explain that? Okay, yeah. So if we write this out, 9 times 8 times 7 times 6. Oh, sorry, not times 6. 9 times 8 times 7. Okay. So if we were to write this out, 9 factorial over 6 factorial. We've got 9 times 8 times 7 times 6 factorial. And that's all over 6 factorial, right? So we can cancel out the 6 factorial, and we're left with 9 times 8 times 7. Right. Yeah. Yeah, and much more often than going from here to here, you're starting with something like this, 9 factorial over 6 factorial, and finding this. Okay? This one's a bit trickier. So if you just look at the top for now, if you look at the top first, we have 15 times 14 times 13, right? So we can do a strategy similar to this one, right? So we've got 15 factorial over what? 12 factorial. Good. Over 12. And right. And then we've got 4 times 3 times 2 times 1 on the bottom. And how can we write that? 4 factorial. Okay? So we can write the question like this. 15 factorial over 12 factorial times 4 factorial. Yes. Yeah. Do you want to? Okay. So if we take a look at the top, the numerator of this question, we have 15 times 14 times 13, right? I'm just going to give myself a bit more space here. So if we have So if we have 15 factorial in the top, like this, right? We can expand that out to 15 times 14 times 13 times 12 times 11 times 10, right? All the way to 1. We can rewrite that by as 15 times 14 times 13 times 12 factorial, right? Does that make sense? Kind of. And then if we're dividing this, what would that give you? Yeah.
So then why would you do 4 factorial over 5 factorial?
Well, on the bottom, we've got this 4 times 3 times 2 times 1 on the bottom, right? Yeah, so we're not canceling anything out in that case.
But it equals 65,000.
Okay, good. Thank you. 65,520. Okay, so first of all, let's take a look at if we have a question like 7 factorial. What does that mean? What does 7 factorial mean? Right, all the way down to 1, right? And there are a few different ways that we can rewrite this now, right? So if we kind of take out the 7 and keep it separate, let's go 7 times, and then we can look at this. We have 6 times 5 times 4 times 3 times 2 times 1, right? So how can we rewrite this in factorial notation? Right. So 7 times 6 factorial is the same thing as 7 factorial, right? Right. I wasn't wrong, no. Yeah, and maybe I should have. Right, so let's take a look at this and let's expand this, okay? So if we expand this 15 factorial, we get 15 times 14 times 13 times 12 times 11 all the way down. We're going to rewrite that as 12 factorial, right? Okay, because that's what's missing. Yeah, that's good. Exactly. So we're manipulating our factorials. And what do we have on the bottom? We have 12 factorial times 4 factorial, right? This one here. Okay, I'll try that in a second. So we're trying to rewrite this in factorial notation, right? So we're trying to get rid of all these times symbols and just use factorials, right? And so we came up with this, and from here, we're going to go back and show that this is equal to this, okay? So we've added this 12 factorial, and you're asking why, right? Well, we can see here, if we expand out this 15 factorial, this 12 factorial and this 12 factorial cancel out, right? And then what we've got after that is the original equation, right? 15 times 14 times 13 over 4 factorial. And of course, this 4 factorial can expand out. And so does everyone see how we go back to the original equation? Okay, good. Sorry? Like this here? Yeah, you would perhaps if you find the final evaluation, it would go to a decimal place. And that's fine. Okay, thanks. Okay, take a look at example 4. So we're asked to evaluate these, so to find the value. Oh, we had plenty of room on the next page. Look at this. So yeah, this is 8 times 7 times 6 factorial. How can you rewrite that? 8 factorial, right. Okay. And then you can find the final evaluation for that. What is that? It says right here. Good. So try B and C by yourself, okay? So if we have 12 factorial over 10 factorial, we can expand it out like this. And then from there, we can cancel things out, right? So what did you get? Did you guys get 132? Good? Yeah. And then for this one here, we can expand it out in a similar way. I'll write it down here. 8 times 7 times 6 factorial over 6 factorial. And I'm just rearranging here on the bottom over 2 factorial because I want to cancel out. This 6 factorial is a bigger one, so I'm going to use that to cancel out. We're left with 8 times 7 over 2. Which equals 28. Are there any questions about that? Yeah, and now we bring in variables.
Why don't we just start that on a whole new lesson? What do you learn two things this lesson and you want to?
Well, tomorrow.
And then we're also having variables for our last example. Maybe.
For this one, I think we're going to be good to keep going. And at the end of the lesson, tell me if it's a little too much. But I think it'll be okay. This is the last part of it, yeah. Okay, so if we have n factorial, we can rewrite that. So in regular factorial notation, we start with the original number, we multiply it by 1 less, and then we multiply it by 2 less, multiply it by 3 less, all the way to 1, right? So if we have n factorial, we can rewrite this as n times n minus 1, okay, times n minus 2. And how far do you know to go? We can do dot, 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 3 times 2 times 1. So you're right. How far do we go? And we don't really know because we have a variable here, right? I'm just saying at the very end, we know we're going all the way to 1, right? So this dot, dot, dot is like the in-between, okay? What we're going to do whenever we have...
How do you know you're going all the way to 1?
Because factorials always go down to 1.
There shouldn't be a part of this lesson, though. I'm telling you. You guys decide what's all lesson.
All right, guys. Yeah, that's true. I don't decide. Let's take a look at the first one here, okay? Because we know that we've been able to cancel things out, right? So just bear with me. What's going to go next? We have n times what? N minus 1. And we can keep writing it like this. N times n minus 1 times n minus 2. But we're not going to do that, right? We know that we can go n times n minus 1 factorial. Well, and then we've got on the bottom n minus 1 factorial. Sorry?
So it just equals n then.
Yeah. So why did we do that? Okay. All right, hold on a sec, guys. So if we're dealing with numbers that we know, like 7, if we have 7 factorial, we already looked at this. We know we can rewrite it as 7 times 6 factorial, right? Now, if we're dealing with numbers we don't know, like n factorial, we can do the same thing, okay? We have n times what's going to be next in our sequence? N minus 1 factorial. Well, this is n minus 1. So, for example, if our n is 7, yeah, that's good. So we're always going down, yeah. This is, yeah. So if our n is 7, so we have 7 here, this n minus 1 would be 6. So we're always going down. Right here? Well, we have a, we're going to keep counting down, right? So that's why we have this factorial, because we're going to keep counting down, n minus 2, n minus 3. We don't know how long we're going to keep going down. But we know that if we can get an n minus 1 factorial in the top, then we can cancel those out. And what we're left with is n. Okay?
So you times the top by the bottom. And that's fine.
So what we've done to the top is we've expanded this n factorial. Okay? We know that this n factorial can be written like this, n times n minus 1 factorial. The same way that 7 factorial can be written as 7 times 6 factorial. Does that make sense? Yeah? So let's take a look at B. We're not going to try to find a final answer for this one. It's not asking us to evaluate, right? We're not trying to find the value of n or the value of this question. What we're, sorry? Yeah, we're trying to put it into the notation. We're trying to simplify, right? Simplify. So this question here, you'll notice that each term goes down by 1, right? m plus 4. Next term is m plus 3, which is 1 less, right? Next term is m plus 2. Okay, yeah, I'm hearing. Yeah, that's good. So this is a simplified way of writing it. Because you can imagine this is going down by 1 each time, all the way to 1, we know, right? Because we have a factorial on the last one. So that would keep going all the way down to 1. So we know that we can rewrite this using the biggest term here, n plus 4 factorial.
Next one's the same. It's just n.
Next one's very similar to A.
Factorial.
This one is a little different, okay? But it's very similar to A. It's not, what did you say, Sawyer? It's not n factorial. Because what are we going to do? On the top, we can expand that out a bit. So n plus 1, what are we going to multiply next? N, okay? And we could keep going down the line. Next would be n minus 1. Next would be n minus 2. But don't do that. We're going to put a factorial there, okay? And that's over n factorial. And then you can see we can cancel this out.
How come you didn't expand the n factorial on the bottom? You expanded the factorial on the top and
This question?
There's n factorial on top.
Yeah.
Expand it to n minus 1.
So the next one, yeah, was n minus 1.
How could you do that for the bottom one?
Here or here? This one?
Yeah, you expand the bottom.
You could expand it more. And I mean, why don't we take a look at what that would look like?
So it'd be n minus 1.
Next here?
No,
Yep.
n minus 1. So then you would cancel the n's.
Well, the n's don't equally. Oh, this is n factorial, right? Whereas this is just n, so they can't cancel each other out. You can cancel out n factorial. We're done. Are there any questions before we get started on the homework? 28. Sorry, 29.